Okay, starting with degrees on the unit circle, we start with 0, and then we go to 30, 45, 60. Those are your special triangle angles, so that's why we use those three and why they're not equally distant apart there. At the top, since this is a 90-degree angle, this is 90 degrees. And these distances are the same all the way around. So if this is 30 degrees from 60 to 90, this is 30 degrees to 120. 15 distance here, so this is 15, this is 135. 15 again is the distance here, so the distance here is 15, this is 150. And then 30 degrees here, 30 degrees here, this is 180. 30 degrees makes this one 210, 15 makes 225, 15 makes 240, bottom of the unit circle is 270, 30 degrees again makes this 300, 15 makes this 315, this is 330, and all the way around we're back at 360 degrees. To convert those to radians, 0 radians should of course be, 0 degrees should of course be 0 radians. 180 degrees is pi radians. That's something you need to memorize. Halfway between 0 and pi is pi over 2. Halfway between 0 and half of pi should be a fourth of pi. 30 goes into 186 times, so that makes this a sixth of pi. 60 goes into 180, which is pi, 3 times, so this is a third of pi. Values that are the same distance from the x-axis have the same denominator in radians. So this one's over 6, this one's over 6, this one's over 6, and it's the next value that doesn't reduce. So this is 1/6, 2/6, 3/6, 4/6 all reduce. This is 5/6 of pi, or 5 pi over 6. 6/6 reduces, 7 doesn't, so 7 pi over 6. 8, 9, and 10 all have common factors with 6, so all of those would reduce over 6, but 11 doesn't, so 11 pi over 6 goes there. Everything that's this distance has a denominator of 4. One-fourth, 2/4 reduces, so this is 3/4, 3 pi over 4. 4/4 reduces, 5 doesn't. 6/4 reduces, 7 doesn't. Everything that's this distance from the axis has a denominator of 3. So this has a denominator of 3, this has a denominator 3, this has a denominator 3. 1/3, 2/3 doesn't reduce, 3/3 does, so this is 4/3. 5/3 doesn't reduce, so this is 5/3. And the only ones we haven't filled in, if this is pi, then the same distance around means that 0 is also 2 pi. And halfway between pi and 2 pi would be 1½ pi, and 1½ as a fraction is 3/2. So that's 3 pi over 2. Then from special triangles, the radius of the circle is always 1. So if the radius is 1 to the 30-degree angle, and we want the coordinates of the point there, if it's a 30, 60, 90 triangle, then the short side is half the hypotenuse, so it is 1/2. The long side is the short side times the square root of 3, so it's the square root of 3 over 2, and that gives us the x, y coordinates of this point. So this point's coordinates are the square root of 3 over 2, 1/2. The sine of this angle would be the opposite of 1/2 divided by the hypotenuse of 1. That makes it 1/2. This is the sine of that angle. Cosine would be adjacent over hypotenuse, giving you the same thing. So for every value on the unit circle, the x-coordinate is cosine, the y-coordinate is sine. If we turn this triangle over so that this is 60, this is 30, the coordinates will just switch, so we won't do that one again. At the 45-degree angle, if the radius is still 1, then the relationship between the side and the hypotenuse in a 45-45-90 triangle is that the side times the square root of 2 is the hypotenuse, and in this case that's 1. So the side is 1 over the square root of 2, which when rationalized is the square root of 2 over 2. And that's what both sides equal here. So the x and y coordinates are both square root of 2 over 2, square root of 2 over 2.